Hey everyone, this is Matt Prez with Converge, and today we're going to carry on video 3 in our Sketchblock series. If you've missed the first two, in the first one we covered the creation and usage of basic sketchblocks. The example we used was a DB9 connector. We learned how to create the sketchblock, how to save it, and how to reuse it to create features on parts. In the second video, we talked specifically about the belt and pulley layout, where we created a basic layout of pulleys with tensioners. We used the belts and pulleys functionality and engaged it so we could have rotation. Then we also talked about ways that we can reuse that information to create solid geometry. Now we want to talk about gear layouts. So again, this is another functionality that sketchblocks can handle. Of course, they do have to be in 2-dimension, but we can plan out more advanced gear sets before ever creating solid geometry. To get started, we're going to create a sketch on whichever plane you like. I'm going to be using the front plane. And we're going to create a basic representation of 3 gears. We're going to be using a gear with a pitch diameter of 2 inches and a gear with a pitch diameter of 4 inches. So we're going to start by drawing these as circles. So just draw 3 circles. And again, I like to put some sort of representation that I know that these are rotating. So it can be a circle, it can be a line, it can be whatever you want. In this case, I'm just going to put a few small circles somewhere inside of the perimeter of these, and then I'm going to add dimensions to the larger circles. So a 2-inch pitch diameter on 2 of these, and then a 4-inch pitch diameter on 1 of them. And now that we have these basic laid out, we're going to go ahead and we're going to select the larger circle and then the circle or line or whatever you put inside of it, and we're going to make that its own block. We're going to repeat this with each of the others. We'll make each of those their own block. And again, we'll come in and we'll simply select this geometry. We'll make a block. And now we have 3 separate sketch blocks. I'm going to go ahead and delete this extra entity here and take a look at what we have. So in order for these gears to work as sketch blocks, we need to be able to do what's called engaging the block. And engaging the block is something that pops up when you select 2 specific sketch block entities that we can apply this to. Now you'll notice that when we first do this, we have 3 sketch blocks, but when we select each of these, we're not getting that option until we make the selection of the outside circles. And now you can see that we have something that's called traction. So this is a relation that pops up only in very specific instances. It's kind of like the Pierce relation when you're dealing with sketches where you want to intersect a spline with another spline on a different plane. Well, this traction only pops up when you have the applicable selections. Once we have it and we click it, it'll essentially make those 2 tangent. So we're going to repeat that process over here with the other 2-inch. So we're going to make the selection of the larger outside diameter. And then we're going to select the smaller one as well. Once we have it, we'll go ahead and add that traction. And then we need to make sure that the centers of these are fixed in space, because if I just start to drag them and move them around, you can see that all these gears are moving. So what I'm going to do is I'm going to drag one to the origin. I'm going to make this one vertical, which will keep it from moving left and right. And because of that traction, essentially the tangency between those two, it's not going to be able to be moved up and down. And this one over here is free to float, and I'm going to make this one horizontal. And again, I'm sort of cheating to get these fully defined. I'm not using dimensions, but ultimately this lets us understand and decide exactly where the locations of the centers of these need to be. Now that we have all 3 of them set, as I start to move one of them, you can see that the others rotate as well. And again, we're dealing with 2 of them that have a 2-inch pitch diameter, and we have 1 of them that has a 4-inch pitch diameter. So the 2-inch ones will be rotating the same amount, so 1 revolution each. However, the 4-inch pitch diameter is going half of that amount every time we rotate. Very similar to our belt and pulley example where we just looked at the diameters of these circles. So what does this mean if you want to get a little bit more advanced? If you want it to look more like a gear set and make sure that everything is interacting, that the gears are meshing, well, we can use the basis of what we have here, and we can use that functionality by creating an additional sketch block. The way that I'm going to do this is I'm going to go to my Tools, blocks, and insert. And we've supplied 2 sketch blocks with this specific instance, and we have a 24 and a 48 tooth gear sketch block. So go ahead and insert those, and I'm going to go ahead and snap it to the center of that. Snap it to the center of that, and once I've got those 2 inserted, I'm going to go ahead and go back to blocks, back to insert, and this time I'm going to insert the 48 tooth one. So the 48 tooth one, based on the pressure angles and the pitches and everything that I selected, will match up with the 4-inch and the 2-inch. So now that I have these in here, these are free to move about. They're sketch blocks, they've been created in the same manner, and now that they're snapped to the center locations of the other ones that we've already put in here, everything's free to move. However, you'll notice that they're not moving each other. They're not engaging the other sketch blocks. And what we want to do is we want to figure out how to make that happen. So as we rotate this around and we know that we have the correct position, the pitch diameter, you can see that the sketch is actually overlapping a little bit. And that's because in reality, this is a basic representation of these gears. They don't have the fillets on all the corners, and there's some leniencies that are taken with these sketches. But it's important for you to identify the true profile of your gears if you want to make sure that the lash between them is as tight as possible, depending on what you're designing. But what we're trying to focus on here is we're trying to focus on how we can engage this information, how we can make all of these turn. And the way to do that is by including these circles inside of the same sketch block, or by making some geometry such as a line that we can align between the underlying sketch blocks. So what I'm going to do is I'm going to edit the larger sketch block, and I'm just going to add another circle to it. So we're going to go from that origin, and this one's going to be a 4-inch pitch diameter, and then we're going to stop that. All right, so now I have that 4-inch pitch diameter. I'm going to go back to my other blocks, and I'm going to delete them. Now, what this is going to do is it's probably going to break a few relations that we'll have to fix, and that's okay. We don't need to worry too much about that. But you'll notice that this one is free to move now, because before they were really driven by the location of the horizontal and vertical constraints and those pitch diameters. But we're going to follow the same process by going to each of these blocks, and we're going to edit them. And this time we're going to add a circle of a 2-inch diameter, and then we're going to exit that block. So now if I move this one around, I have that larger circle that's there. You can see it's included in that block. And then this one over here, it's free to move about. You can see there's a circle there, and everything's good because these are the same blocks. So once I add it to one, it'll add it to the other. Now what I want to do is I want to engage those blocks. And again, the selection is important. We're going to make sure that we select the 2 and the 4-inch diameter circles, and we engage those 2. Then we follow that same process over here. We'll grab the 2-inch and the 4-inch. We'll use that engage blocks. Then we can go back and add the constraints and relationships that we had before by making vertical and horizontal. Once we have this, now we can start to rotate everything. One key thing that is likely important here is the orientation of the teeth themselves. So when we select this information, you can see that we have this traction. If I delete that, and then I start to rotate this around to a position that makes sense, once I'm happy with its position, I can go back and I can re-imply that a gauge. Now when it rotates, all the teeth mesh as they should. So there is some functionality and some orientation that we need to be careful with, but you can see in this instance that the gears slightly are overlapping in this case. So I'm going to select this circle over here, and I'm going to find the constraint for engage, select it and delete it. Then I'll rotate this instance, and once I'm happy with its position, again I'll select those 2 circles, I will engage, and then we'll OK that. So now as I turn one of these gears, all of them turn, right? So this is a little bit more involved in terms of getting it set up besides just drawing circles, but you can get this information very easily. And the way that I actually created these blocks was to download the gears I was interested in from McMaster-Carr, and then I went through its feature tree. I deleted any fillets that were on the edges of all the teeth just to simplify the sketch block itself. and then I just converted the entire face of the gears to a sketch block. So that process is, it's very similar if you use convert entities on any other geometry. It's the same thing. It just takes a solid body, the edge of a solid body, and it converts it to a sketch entity. Select it, make it a block, just like we did in our first lesson in terms of creating a sketch block from a DB9 connector. So what do we do from here? What's the next step in this process? Well, just like with our belts and pulleys, we can come in and we can extrude this information. We need to select what we want to extrude, and then we'll have to come through, in this case, turn off the thin feature option, and we want to extrude the entire inside of the sketch region and start to build a gear from it. So again, what you do from here, the information that you take away from this, really depends on what you're designing. The last thing that I want to show you is I'm going to create a new sketch. I want to hide sketch 1 for right now. And I'm going to create a new sketch, again, just on any plane. It doesn't really matter for these examples. We're just going to create a sketch on the front plane. And this time, we're going to create one circle. I'm going to use the line tool just to put in some representation so that I know that it's rotating. And then I'm going to create a rectangle. And what we're going to do from here is we'll convert each of these to a block, just like we did with our other examples. Go ahead and convert this to a block as well. I'll place this one at the origin just to fully define it. I'm going to make sure that one of these edges is horizontal, because once we create a block, it loses those external relationships that make a rectangle horizontal or vertical. Then we're going to select this line, control select the circle, and use that engage block. Now what we've done is we've created a representation of a rack and pinion. Again, the circle represents the pitch diameter, and the same thing on the rack. It would represent the diameter for the center of each of the teeth. So this is another way that we can create these mechanical assemblies and represent our gear systems in 2D before we ever design these 3D parts. So again, thanks for watching. If you guys have any questions, of course, let us know. And if you're following along with the series, the next lesson we're going to talk about creating linkages. And we'll use an example of basic 4-bar linkages that you would see in lots of mechanical designs.